Hey, everyone.
What are you doing for Waymo, Cruise, and Uber?
Just submit and then.
يا شباب
مكان عن جد
Hello everyone. So today, from tomorrow, I'm gonna start studying math. From tomorrow, it's Ramadan, which means I'm gonna start fasting. So I will not dedicate it all the effort for studying, like it will be mostly half of it. The others, I need to pray, I need to fast, I need to take care of myself, just for this month. Then I will resume back to my normal schedule. So yeah, today I'm kind of had a headache. I don't know, I didn't sleep even well. Been working all the day since morning. Even like I had many things to do, so I'm just gonna try to watch some videos. Like I don't think so even I'm gonna like just watch random things to see what is there are updates. What is here? Like this is one seems to be good, but I think this is
احنا عندنا مرحلة من الخطر في سنة 2025.
عن أي خطر يتحدث محمد جودة؟
المرحلة دي هيتغير فيها كيان البشرية زي ما نحن نعرفه.
أفلام الخيال العلمي هل تتحول إلى حقيقة؟
الحقيقة انتهت. عدد الوظائف اللي هتختفي في خلال ال5 ل7 سنين اللي جايين هيسبب مجاعات.
المستقبل رهين بيد من يملك الذكاء الاصطناعي.
أنا خايف جدا من تصرفات البشر باستخدام الذكاء الاصطناعي.
عسكرة الذكاء الاصطناعي.
الهدف الأول للحكومة الأمريكية من الاستثمار في الذكاء الاصطناعي هو بناء أسلحة تعتمد على الذكاء الاصطناعي.
مدير الأعمال السابق في جوجل إكس ومؤلف الكتب الثلاث الأكثر مبيعاً حول العالم عن مستقبل الذكاء الاصطناعي ومعادلة السعادة يكشف الحقيقة، يطلق التحذير الأخير قبل فوات الأوان.
الحرب انتهت قبل ما تبتدي.
محمد جودة, thank you for having us. شكرا على استضافتك لنا. نحن كثير سعيدين انه جينا لعندك.
اهلا وسهلا.
اليوم نحن هون موجودين عم نبحث عن الحقيقة.
$40 zaručených milionářů v pátečním losování Sportky. Vsaďte na pátek plný tiket a jste ve hře.
عم نبحث عن الحقيقة، يعني العالم مشغول بالحروب، بالصراعات، سباق على من سيحكم العالم ونظام عالمي جديد عم يتشكل، بس بالمقابل في نظام عالمي آخر يتشكل بصمت. أصحابه أو أقطابه هم أصحاب الشركات التكنولوجيا والذكاء الاصطناعي، ويمكن يكون هذا أخطر ما يكون على مستقبل البشرية.
ده كده اللقاء بتاعنا كده خلاص ممكن نخلص على كده. هو ده ملخص العصر اللي احنا عايشين فيه، انه معظم يمكن بسبب الطريقه اللي بنغطي بيها الاخبار بتاعتنا، معظم وقتنا واهتمامنا محطوط في سياسات، في اقتصاديات، في مواضيع زي مثلا كوفيد، لما الكورونا لما كانت جزء من حياتنا وهكذا. وده بيعطينا جزء من العتامة لو عايزة على المواضيع المهمة. أنا في رأيي أنه أهم 3 مواضيع في حياتنا النهاردة هما المناخ وتغير المناخ، هما الذكاء الاصطناعي، وفي رأيي أنا موضوع تعديل الجينات، إن احنا
let's continue the math history.
I used to spend dozens of hours every single week proofreading. I was constantly fixing run-on sentences, unclear syntax, and repetitive language by hand until I found Grammarly. Grammarly is the AI writing partner that helps professionals write better, faster. Maybe it's a list of creative ways to decorate your planner, or maybe it's an email delicately explaining to a coworker that you need a few more days to complete a project. Grammarly will create.
So did their intellectual vigor.
I used to spend dozens of hours every single week proofreading. I was constantly fixing run-on sentences, unclear syntax, and repetitive language by hand until I found Grammarly. Grammarly is the AI writing partner that helps professionals write better, faster. Maybe it's a list of creative ways to decorate your planner, or maybe it's an email delicately explaining.
By 330 BC, the Greeks had advanced their imperial reach into old Mesopotamia. This is Palmyra in central Syria, a once great city built by the Greeks. The mathematical expertise needed to build structures with such geometric perfection is impressive. Just like the Babylonians before them, the Greeks were passionate about mathematics.
The Greeks were clever colonists. They took the best from the civilizations they invaded to advance their own power and influence. But they were soon making contributions themselves. In my opinion, their greatest innovation was to do with a shift in the mind. What they initiated would influence
Syria, a once great city built.
Calculate this number to an accuracy of 4 decimal places shows an amazing arithmetic facility, as well as a passion for mathematical detail.
The Babylonians' mathematical dexterity was astounding, and for nearly 2,000 years they spearheaded intellectual progress in the ancient world. But when their imperial power began to wane, so did their intellectual vigor. By 330 BC, the Greeks had advanced their imperial reach into old Mesopotamia. This is Palmyra in central Syria, a once great city built by the Greeks. The mathematical expertise needed to build structures with such geometric perfection is impressive. Just like the Babylonians before them, the Greeks were passionate about mathematics.
The Greeks were clever colonists. They took the best from the civilizations they invaded to advance their own power and influence. But they were soon making contributions themselves. In my opinion, their greatest innovation was to do with a shift in the mind. What they initiated would influence humanity for centuries. They gave us the power of proof.
Somehow they decided that they had to have a deductive system for their mathematics. And the typical deductive system was to begin with certain axioms which you assume are true. It's as if you assume a certain theorem is true without proving it. And then using logical methods.
Innovation was to do with a shift in the mind. What they initiated would influence humanity for centuries. They gave us the power of proof.
Somehow they decided that they had to have a deductive system for their mathematics. And the typical deductive system was to begin with certain axioms which you assume are true. It's as if you assume a certain theorem is true without proving it. And then using logical methods and very careful.
Innovation was to do with a shift in the mind. What they initiated would influence humanity for centuries. They gave us the power of proof.
Somehow they decided that they had to have a deductive system for their mathematics. And the typical deductive system was to begin with certain axioms which you assume are true. It's as if you assume a certain theorem is true without proving it. And then using logical methods and very careful steps, From these axioms, you prove theorems. And then from those theorems, you prove more theorems. And it just snowballs that way.
Proof is what gives mathematics its strength. It's the power of proof, which means that the discoveries of the Greeks are as true today as they were 2,000 years ago. I needed to head west into the heart of the old Greek Empire to learn more. For me, Greek mathematics has always been heroic and romantic. I'm on my way to Samos, less than a mile from the Turkish coast. This place has become synonymous with the birth of Greek mathematics, and it's down to the legend of one man.
His name is Pythagoras. The legends that surround his life and work have contributed to the celebrity status he has gained over the last 2,000 years. He's credited, rightly or wrongly, with beginning the transformation from mathematics as a tool for accounting to the analytic subject we recognize today.
Pythagoras is a controversial figure. Because he left no mathematical writings, many have questioned whether he indeed solved any of the theorems attributed to him. He founded a school in Samos in the 6th century BC, but his teachings were considered suspect, and the Pythagoreans a bizarre sect.
I knew I was underwater. I just didn't realize I was this underwater. If you're stressed about your paper, just get...
There is good evidence that there were schools of Pythagoreans. They may have looked more like sects than what we associate with philosophical schools, because they didn't just share knowledge, they also shared a way of life. They may have been communal living, and they all seem to have been involved in the politics of their cities. One feature that makes them unusual in the ancient world is that they included women.
But Pythagoras is synonymous with understanding something that eluded the Egyptians and the Babylonians: the properties of right-angled triangles. What's known as Pythagoras' theorem states that if you take any right-angled triangle, build squares on all the sides, then the area of the largest square is equal to the sum of the squares on the two smaller sides.
It's at this point for me that mathematics is born and a gulf opens up between the other sciences. And the proof is as simple as it is devastating in its implications.
Place 4 copies of the right-angled triangle on top of this surface. The square that you now see has sides equal to the hypotenuse of the triangle. By sliding these triangles around, we see how we can break the area of the large square up into the sum of two smaller squares, whose sides are given by the two short sides of the triangle. In other words, the square on the hypotenuse is equal to the sum of the squares on the other sides. Pythagoras' theorem. It illustrates one of the characteristic themes of Greek mathematics: the appeal to beautiful arguments in geometry, rather than a reliance on number.
Pythagoras may have fallen out of favour, and many of the discoveries accredited to him have been contested recently. But there's one mathematical theory that I'm loath to take away from him. It's to do with music and the discovery of the harmonic series.
The story goes that walking past a blacksmith one day, Pythagoras heard anvils being struck and noticed how the notes being produced sounded in perfect harmony. He believed that there must be some rational explanation to make sense of why the notes sounded so appealing. The answer was mathematics. Experimenting with a stringed instrument, Pythagoras discovered that the intervals between harmonious musical notes were always represented as whole number ratios. And here's how he might have constructed his theory.
First, play a note on the open string. Next, take half the length. The note almost sounds the same as the first note. In fact, it's an octave higher, but the relationship is so strong we give these notes the same name. Now take a third the length. We get another note which sounds harmonious next to the first two. But take a length of string which is not in a whole number ratio, and all we get is dissonance.
According to legend, Pythagoras was so excited by this discovery that he concluded the whole universe was built from numbers. But he and his followers were in for a rather unsettling challenge to their worldview. And it came about as a result of the theorem which bears Pythagoras' name. Legend has it, one of his followers, a mathematician called Hippasus, set out to find the length of the diagonal for a right-angled triangle with two sides measuring 1 unit. Pythagoras' theorem implied that the length of the diagonal was a number whose square was 2. The Pythagoreans assumed that the answer would be a fraction. But when Hippasus tried to express it in this way, no matter how he tried, he couldn't capture it. Eventually he realized his mistake. It was the assumption that the value was a fraction at all which was wrong. The value of the square root of 2 was the number that the Babylonians etched into the Yale tablet. However, they didn't recognize the special character of this number, but Hippasus did. It was an irrational number.
The discovery of this new number, and others like it, is akin to an explorer discovering a new continent, or a naturalist finding a new species.
Plato was enraptured by the Pythagorean world.
Indeed, the importance Plato attached to geometry is encapsulated in the sign that was mounted above the Academy. Let no one ignorant of geometry enter here.
Plato proposed that the universe could be crystallized into 5 regular symmetrical shapes. These shapes, which we now call the Platonic solids, were composed of regular polygons assembled to create 3-dimensional symmetrical objects. The tetrahedron represented fire. The icosahedron, made from 20 triangles, represented water. The stable cube was earth. The 8-faced octahedron was air. And the 5th Platonic solid, the dodecahedron, made out of 12 pentagons, was reserved for the shape which captured Plato's view of the universe. Plato's theory would have a size and continue to inspire mathematicians and astronomers for over 1,500 years. In addition to the breakthroughs made in the Academy, mathematical triumphs were also emerging from the edge of the Greek Empire, and owed as much to the mathematical heritage of the Egyptians as the Greeks. Alexandria became a hub of academic excellence under the rule of the Ptolemies in the 3rd century BC, and its famous library soon gained a reputation to rival Plato's Academy.
The kings of Alexandria were prepared to invest in the arts, in culture, in technology, mathematics, grammar, because patronage for cultural pursuits was one way of showing that you were a more prestigious ruler and had a better entitlement to greatness.
The old library and its precious contents were destroyed when the Muslims conquered Egypt in the 7th century. But its spirit is alive when the Muslims conquered Egypt in the 7th century. But its spirit is alive in a new building. Today, the library remains a place of discovery and scholarship.
Mathematicians and philosophers flocked to Alexandria, driven by their thirst for knowledge and the pursuit of excellence. The patrons of the